map, so you need to check. Normally here by F, there will be brackets here which will show you how many variables do you have, right? W, X, Y, Z. So here, the first thing that we did is that you take this and you represent it in a binary format, because this W has a complement. Any variable that has a complement is represented by a binary 0. If it's high, if it has no complement, like here, this W, it's represented by a 1, right? So here you're getting 0, 0, 0, 0 for this term, right? Here you're going to get 1, 1, 0, 0, all right? So the most important thing, again, remember I said this is the trick that your lecturer like to kill you with. So she may specify that use WX as the
Rows.
columns, for example, as
Yeah,
rows.
rows.
Now it will be different. It will be different. It means your WX must be here by YZ, right?
So
And then
just a second, Larry. So always
mhm.
in the exam, there will be a note saying that please use WX or whatever, whether it is AB or WX or whatever it is. So you should always use that as rows. So you should always use that as rows.
Okay,
If I don't
perfect.
specify, you can just use whatever you like. But if I specify, if I give the note saying that please use WX as rows and YZ as columns, you should go according to that. Yeah,
Yes,
thank you. Yeah.
exactly. So that's what I wanted to explain, guys. So remember that note is very important. If there's no note, we have practiced both ways, where WX is here and where YZ is here. So from here, what you do is that, for example, this is 0, 0, 0, 0. You know the value of W and X is 0, 0. So you go to the cell, you go 0, 0, it's here in the first column, right? And then YZ 0, 0, it's in the first row. So in this cell, you're going to represent it by a 1, right? Then you look for this one, 1, 1, 0, 0, column 1, 1, and then 0, 0 row, it's a 1 here. So everything all together, whatever you get, these combinations that you're going to get here, you're going to represent by a 1, right? And then we look for groups. Remember I said when you look for groups, you look for the biggest group. So the biggest number of ones adjacent to each other. So in this case, the number of ones that were adjacent to each other, we first look at 8. There is no 8 here. There's 4. So we saw that we have this 4, and we have this 4, and we have this 4, right? Then now, quickly, before I give the lecture a chance, then from there, you look for variables that do not change states, right? For example, your W here was
Larry, just I want to add one more thing. You should always
okay.
form groups in the form of like 2 to the power of n. Like n, where n is equal to, like suppose say n is equal to 1. So you can use like 2 ones adjacent to each other as one group. If it is 2 to the power of 2, that means 4. So in the form of like 2, 4, 8.
8.
So you should always use the groups in the form of 2 to the power of n. Yeah, you can carry on.
All right. Yes, yes. So that's why you get the biggest group as, for example, 8, 4, 2, 1. So it's 2 to the power something, right? So you can't group 3 ones together. So that's what the lecture is trying to say. Okay. So now here, for example, in this group, we can see that this group consists of only one column. In this column, the value of W is 0, the value of X is 0 in this group, right? So we're going to take this because the states do not change. The states for the value of W and X is consistent, right? It's constant, so it doesn't change. So W, if it's 0, we know it's denoted by a not W, right? And then X, not X. So now let's check your Y and Z in this in this group. So this group, the value of Y in the first row was 0, which is good. Second row it was 0, which is good. But in the third row it became a 1. So it changes states. We're going to throw away the Y, right? Now we're going to Z. Z in the first row is 0. In the second row it's a 1. So it changes states. We throw it away. That's why we have not W and not X.
And one more thing, easy to just grasp. So when there is a ones in the column like this, when it is grouped, then you can only consider the Y column, this W bar, X bar. That's it. It's an easy way to remember.
Perfect.
whole,
Yes,
yeah,
that's
the
very
first
true.
column.
Yeah.
When the whole column is grouped, you can
Mhm.
consider this as W bar X bar. So similarly, when you come to the third column, see, it is just WX. See,
It
that's it.
is.
Easy to remember. And when you just move to the second row, this whole thing is grouped. The whole row is grouped. So then it is Y bar Z. That's it. Very easy to remember.
Thank you. Thank you. Can I move to the next one? Logic circuit. Do you want to open it or must I look for it?
Yeah, you can open it, Larry.
Okay. Let's look for logic circuits. So some call it logic circuits, some call it logic gates. I think I'm looking for logic gates. Okay, let's try this one. Should I explain this one or do you want to explain it?
Yeah. So the easy way to remember this logic gates is when there is plus sign here, that means plus always represents OR gate. When it is like A, B, C, D, that is A multiplied by B, C, D. So that means it is ANDed. So that means they use AND gates. When there is plus sign, it is called OR gate. So this A, B, C, D. So just put A, B, C, D here and it says A multiplied by B, C, D. So that means all these are ANDed. That means all these inputs are ANDed. So that means they use AND gate. So then the output will be A, B, C, D. So that means you connect all inputs with AND gate. So finally, when it says plus here, so that means it should be connected with OR gate finally. So this plus here is nothing but this final OR gate here. So here the next term is D into A plus C. So first what we should do, take D input, connect it with AND. And it should be connected because it's bracket here. So we should connect it with AND gate here. Here, the AND gate. A plus C. Again, you should connect it with A. This A comes and connects to OR gate. And C input also comes and connects to the OR gate. And this A plus C and D should be connected with AND gate. So the final input will be D and A plus C. This A plus C is the OR gate and D connected to this is AND gate. And whole output should be connected to the OR gate because again it says plus next to it. So it should be connected to the OR gate. So always already you have OR gate here. You should just connect it to the OR gate, the output of that. The next coming to the third term, AB bracket AC plus BC. So this AB is not, again it should be ANDed. A input and B input should be ANDed. So that means A and B should have an AND gate. Then again it should be ANDed with AC plus BC. Then again take AC. That means A input and C input should be ANDed. See here A input and C input should be ANDed. And again BC also should be ANDed here. BC here. So these two should be connected with OR gate because there is plus sign here. So always plus represents OR gate. So this both should be connected with OR gate here. Then again this A plus BC should again be ANDed with AB here. So again you will have an AND gate here and finally the output you should write it as AB bracket AC plus BC. So now because all these three terms are having connected with the OR gate. So this output also should be connected to the OR gate. So now the final output will be this F here. It's very easy to remember. Logic circuits. It's very easy. The first thing, because it has got 4 inputs, because it says A, B, C, D. First take 4 inputs in the beginning. Then start connecting each term. And just see how 2 terms are connected to each other. Whether it is OR gate or AND gate. So first take the first term A, B, C, D. Because it is A into B into C into D. So just connect it with AND gate. Then it says plus. So that means there should be some OR gate connected to each term. So you take the OR gate here. So don't worry about the OR gate now. So next take D bracket A plus C. So what you should do is take A input and C input and then put OR gate and then connect to D with AND gate and just leave it like that, the output. Next, take the third term. So we are now considering each term. So the third term is AB bracket AC plus BC. So this AC plus BC should be ANDed with AB. So take AC and A and C. Just do the AND gate. Then put the AND gate. And then again take BC. That means for B and C input, put the AND gate. And both should be connected with OR gate because there is a plus sign here. So connect it with the OR gate and just the output of that. Then what we have to do, it should be ANDed with AB here because it is a bracket. So A and B input, it should be ANDed. Again, it should be ANDed with AC plus BC. All these 3 terms again should be connected with OR gate finally because there is a plus sign for each term next to it. That's it. Hope you have followed this logic circuit. So we can move to the next one. If you have more logic circuits, yeah, we can next move to the next one more logic circuit because this logic circuit carries at least 8 to 10 marks. So if you are familiar with this logic circuit, that means easily you can get 10 marks easily. So now here it says WX, Y, Z bar. Then for the whole thing, again bar. So first what you have to do is, first take W. There are 4 inputs here. W, X, Y, Z. First take 4 inputs. Next W, X, Y and Z bar. They should be ANDed. First they should be connected with each other with AND gate. So first put the AND gate. But here for the you have Z bar here. So for the Z you must put first inverter, then connect it to AND bar. Then for the whole AND bar, AND gate, there is one more bar for the whole inputs. So then you should again put here this NAND gate. This is called NAND gate. AND gate with inverter is called NAND gate. So just this is one term. Just keep it like that. Next, take the second term. The second term says W bar, X bar, Y bar and Z bar. So all these 4 should be again connected with AND gate. So let's first consider this Y bar. So Y bar means Y, take the Y input. Next, add an inverter to it. Then it becomes W bar. Next, take X, add an inverter to it. It becomes X bar. Similarly for Y bar, similarly for X bar. But all these inputs they should be connected with AND bar. So connect with AND gate here. So your output will be W bar, X bar, Y bar and Z bar. Next, the third term. Let's consider the third term. The third term says W bar. In the bracket, it says X plus Z. So first you should take this input W and just add an input inverter to it. It becomes W bar. So for this W bar, it should be ANDed with X plus Z. So now consider X plus, whenever there is X plus sign, you should always use the OR gate. So for X and Z, we are using the OR gate here, down. So this OR gate X plus Z and the W bar, it should be ANDed. That means you should use for these two AND gate. So finally, for all the outputs here, for the three terms, you should use, because there is plus sign here, you should use OR gate finally. That's it. If any one of you have questions, you can raise your hand. Logic circles are very simple. You can easily get full marks. Just you have to remember what is plus and what is like AB is like A should be ANDed with B. That means A and B inputs should have an AND gate. If I say A plus B, that means for A input and B input, you are using OR gate. If you understand these two, you can easily attempt this question without fail. This is, I think this is one more Karnoff map.
Yeah, this is Karnaugh map, Karnaugh maps.
Yeah, we can also, yeah.
Okay, so you wanna touch Karnaugh maps or?
Yeah, we finished. And also the De Morgan's theorem. So you have two theorems. One is, the first theorem says that A plus B whole bar is A bar into B bar. And what is AB whole bar? A bar plus B bar. This, if you know these two theorems, you can solve the problems applying De Morgan's theorem. You can easily solve this one. See, A plus B whole bar is equal to A bar plus B bar, or X plus Y whole bar is equal to X bar plus Y bar. This is one. So you can easily, yeah, this is one solution. And also you should be familiar with Boolean laws to solve this De Morgan's theorem. Examples. So those 12 Boolean laws and 2 De Morgan theorems, if you are familiar with, you can easily attempt Boolean algebra. No doubt.
Okay, just want to show them what you are saying.
Yes.
Just give me less than 5 seconds. So guys, nothing is new here. This is basically what we've been doing.
Doing in assignment 2 and assignment 3. Yes.
Yes. So now she's just saying that, remember De Morgan's theorem, even though I still use my high school terms, break the line, change the sign.
Yeah.
It's this 2. This is equals to A. You break this line, then you change the sign here. This is an OR gate. You're going to change it into A, AND gate, but you're going to break this line into 2. Remember, we even proved this with the truth table to show that it's equal.
Yes, yes.
So the second one is this. Still, you just break the line and change the sign, right?
Yes.
Just break the line.
A bar plus B bar. Yes.
B bar.
Yes. And this is for 2 inputs. So if you have like 3 inputs, also the same. Suppose if you have like A plus B plus C whole bar, then similarly, you have to write A bar to B bar into C bar, or A, B, C whole bar will be equal to A bar plus B bar plus C bar. Yeah, for any inputs.
Remember, we got this, I think, in the last session 2 weeks back. We did something similar to this one. So it's basically the same. You just break this line, then you change the sign here, right?
Yes, that's it. So with this, you can solve the problems very easily. And also, while using the when you're applying the De Morgan's theorem for the expressions, also you must be familiar with Boolean laws. See, for this example, you have like A, B bar plus CD plus EF bar whole bar. So then by De Morgan's theorem, you're writing, you're taking like each as one term, like AB bar is one thing, CD is one, EF bar is one. So then you have like AB, because A plus B plus C, it is in the form of A plus B plus C whole bar. So now what you do, AB bar is one term. So what you do, A bar. So that means AB bar whole bar. That is one term plus CD bar plus EF bar whole bar. Again, you have like EF bar double bar. When you have this EF double bar, which is nothing but EF by Boolean law. So that's why while attempting the De Morgan's theorem examples, questions, so you should also be familiar with Boolean laws.
So the Boolean laws are those 12 laws that we have in exam notes 1. So remember we proved this one. We said imagine, for example, this is double complement, right? Let's say the value of A was 1, right? Then you complement it once, it's going to become 0, right? Then if you complement it again here, complement like you invert it, it's going to become a 1. So do you see why this 2 falls away? So A double bar is equals to just A. So this is what it means. That's why it's falling away. It's because it's the same. The value will be the same because you're going to invert it. Let's say a light is on. You're going to switch it off. Then you're going to switch it on again. Do you understand? So that's why it will remain on.
Yeah, you're back to...
Okay,
yeah.
let me
So
go back.
I think I missed like 2's complement. We should let us
Yes.
go to next 2's complement as
Okay.
well. So yeah.
Complement. There's a very nice worksheet for complement. Let's see.
These are very, very simple questions. Just you need some logic here, and just you should like try.
Yeah. So do you want to start with 1
Yeah,
before
1's
we go to
complement.
2?
2's complement.
Okay.
So first let us do 1's complement of any number. So let's say if you take 10001 100110001, let's say, then the 1's complement will be exactly opposite to that. When you say 1, it will be 0. When it is 0, it will be 1. So similarly, you have to do for everything. Like if it is 1, instead of 1s, you should write 0. Instead of 0, you should write 1. So once you have 1's complement, then the 2's complement will be just, you should add 1 to it. Yeah, let's say a simple one. Let's say 10110. So 1's complement of this will be like 01001. Yes. Then the 2's complement of this number will be just, you should add 1 to it. That's it. Then it will be 1 plus 1 is always 1, 0. So 0 will be here and 1 will be your carry. So again, when you move to the left side, again 1 plus 1 is again 1, 0, which is 0 and again 1 carry. Oh,
I'm a bit confused. This is 1 plus 0 here.
1 plus 0, yes. I'm taking the upper one. Yeah, 1 plus 0 is 1 and 0 is 0. 1 is 1. 0 is 0. Yeah, that's it. So this is 2's complement. So always 2's complement is 1's complement plus 1. So the first step would be doing 1's complement of the given binary number, then adding 1 to it will be your 2's complement. Next one. Yeah. So what else did we miss? Oh, addition in number systems.
Let's add something easy, or this one is going to be
Let's go
difficult
to
for
the
them.
binary addition. Yeah. Let's consider
some 1
binary addition.
0 1.
Yes. So this is simple. So let's make it like another 1 to the left side. Because 0 plus 1, 0 plus 1,
yeah,
1.
It's going to be 1 1 1.
1. Okay. So let's do this one. So 0 plus 1 is 1. 1 plus 0 is 1. 0 plus 1 is 1. But here 1 plus 1, always in binary thing, 1 plus 1 is 1 0. 0 and 1, because there is no more digits next to it. So you should just put it 1 0 as it is. Yeah. Yeah, that's it. So let's do like where you will get like 1 plus 1 plus 1.
Okay. Let's see. So 1 plus 1.
Yeah, that's it. It's enough. Just to make them understand the addition. So 1 plus 1 is always 1 0. So 0, you have to put it here, and 1 is always the carry. So next, 1 plus 1 is 1 0. 1 0 plus 1 is always 1 1. That's it. Yes. Yeah. Next, let's go to octal addition.
Octal addition. Where do I have it? Let me come up with one.
Yes.
Octal is basically from 0 to 7.
Yes.
So let's say 7 2 1 base 8. Then we can add it with 5 3. Is it fine like this?
Yes. Put two here. Two here. 2 next. Under 7, you put 2.
Okay, 2. Okay.
So 5 plus 1, because from in octal, 0 to 7 digits will be the same. But when you say 8, then it changes to 10. Yeah, 0 to 7. Yeah. So 5 plus 1 will be 6. 2 plus 3 will be 5. And 7 plus 2 is 9. So 9. Then in octal 9. So we should show them the table there. Just a second. Let me. Do you have the table? Yeah. So 9 in octal will be. Let's show them the.
1 2 4.
No, but if it is always good for them to remember the table, because this is all tedious thing. Let me just. Yeah.
Okay, another way.
I can
okay.
Copy
can
the.
share.
I can share this one. Let me just. I will share the screen. Just a second. This one. You can, I think, yeah. Yeah, see here. See. So when you see, when it's 10 is again here, yes. When you say 8, it will be 10. When you say 9, it will be 11 in octal. Can you see, Larry?
Yes, 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 I
Yeah,
can
yeah, yeah.
see, yes.
So until 7, the digits remain the same. But when it says 8 or 9, from 8 onwards, it changes. So in octal, 8 is 10. In octal, 9 is 11. So now we have here 9. So now 9 is 11. It's always good to remember this table, this octal table. This is very simple. So until 7, the digits remain the same. From 8 onwards, it starts from 10. 10, 11, 12, 13. So when you say 9, it is 11. It's easy to remember.
Okay, perfect, understandable. So let's answer this one.
Let's do one more. So now everyone know that 8 starting from 8 in octal is 10. So now let's do one more problem. It's easy
So
to.
this 9 will be 11.
Yes.
Right?
Yes. Yeah. You can. Let's solve one more example so that they'll be familiar with.
Okay, what can we use?
Any number like 75 plus 82. Simple.
82. Okay.
I
So
think
this one is less than 8.
Yeah.
So it's going to be fine.
I think you are not sharing the screen, I think, because I can't see the number. Yeah.
Okay, sorry.
Yeah. Yes.
Okay. All right. 75 plus 82. This is octal. The base 8.
We still can't see the screen.
Yeah, now we can see. Yeah, see. So now here,
Okay.
75 plus 82. So 5 plus 2, 7. No problem. So because from in octal, 0 to 7 remains the same. So from 8 onwards, it changes. In octal, it is different. So now 7 plus 8 is 15. So 15 means 8 is 10, 9 is 11, 10 is 12, 11 is 13, 12 is 14, 13 is 15. So now the answer will be 137.
1378. Let's
That's
see.
it. Very simple.
8 is 10.
8 is
9
10.
is
9
11.
is 11. 10 is 12.
Okay. 10 is 12. So the difference is just 2 here. So for example, so from this 15, I can just minus 2 and put a 13 here.
Yeah. So 8 is 10, 9 is 11, 10 is 12, 11 is 13. 12 is 14.
12 is 14.
13 is
15.
14 is 16. 15 is 17. Yeah.
Yeah. Let me skip 14. 15 is 17.
Yeah. So it is 17. So it should be like 17 here. 177 is the answer. Our final answer is 177.
Oh, 177.
Yeah.
Okay. Yeah. Okay, it makes sense.
Yes. So you should only remember this. Starting from 8 in octal is 10, 9 is 11, 10 is 12. So it goes on like that. So because we have 15 here, 7 plus 8 is 15. So in octal, it should be 17.
Okay, can I just check another method quickly
Yes.
in less than
Yes.
2 minutes? So remember, again, you can represent this into binary. Normally, I like converting to binary. So 5 we know is, let me just write it here so that you can see what I'm doing. 1, 2, 4, right? We know 5 is 1, 0, 1. So it's 1, 0, 1 because it means the 4 is present and the 1 is present. The spade is not present. And then 7, all of them are 1s, right? And then 2, for example, 2 is going to be 0, 1, 0.
14
0,
is 16.
1, 0. And then 8. Oh no, I get what you're saying. Oh, but yeah, we can still do 8. 8, if it's like this, 8 is going to be, it's going to be, what do we do? So how do we say 8 is going to be 1, 0, 0, 0, 1, 0, 0, 0, right? So let's add and see first. So this is 1, this is 1, this is 1. Okay, this is true. You see it's already a 7. This is 1, this is 1, this is 1, this is also a 7. So remember you group in threes, right? And then this is 1. Okay, so 0, 0. So this will be a 1 here, right? So the answer will still be 1. This is 7, 7, 7. Okay.
Yeah. Yes.
Correct. All right.
Yes. So there are different ways of solving the problem. So the
Yeah.
the
easiest is this
easiest
one.
way is like this. So in octal, 0 to 7 remains the same. From 8 onwards, it takes like in octal, 8 is nothing but 10. 9 is 11. 10 is 12. That's it. So easy way to
Okay.
remember, and just you can quickly put the answer.
Yeah,
Yeah,
this one is
it's-
the easiest.
Yeah,
I
it's the
think.
easiest one. Yeah. So now next, let us do the hexadecimal one. Hexadecimal addition. This is the
Okay.
last one for today.
Let's go. Hexa is 16. Total of 16. I'm just trying to think. A is 10. B is 11. It ends with 15, which is F.
Correct. So now
F.
10 will be A. So I can share as well. So let me
you can
just
share for this one.
Yeah. Let me share this one. Easy way to remember. See here. See here. See, for the decimal numbers, see, until 9, for hexadecimal, until 9, it remains the same. Whereas in octal, until 7, it remains the same. But here, until 9, it remains the same. From 10 onwards, it takes like A. 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, 15 F, and so on. So this is the easy way to remember. So let's do one example. Hope everyone followed this table. So let's do one problem. Larry, are you still there?
Yes, I'm here.
Yeah.
Oh,
are you
all right.
checking for the example?
Yeah, I was looking, but it's fine. Let's just figure out one out of our brains.
Yeah.
So we can say, for example, let's say
hexadecimal, anything.
8.
Yeah.
I know 8A. 8A.
We can't see the screen.
Oh,
Hope you. Yeah. Yes.
okay. Let me
Just
share.
let's do one example because we are almost nearing to 7 now.
Yeah. Okay.
Yeah. Just so with this
Let's
we will
say
stop. Yeah.
8A Then let's
Yeah.
2, 2, 5.
Yes. Okay.
Right. So
So
let's say this is 5 and this is a 2 to the
yeah.
base 16.
So A. So what is A? A is nothing but in normal decimal, it is 10.
10.
10 is A. So that you should always remember that 10 is A. So 10, you should think in your mind that A is 10. So 10 plus 2 is 12. But what is 12 in hexadecimal?
C.
Mm.
11
Yes.
is B, 12 is C.
Yes.
So the value here will be C, right?
Yeah.
Okay.
Yes. 8 plus 5 is 13. But what is 13 in octal? Is D. Yes. Because 10 in octal is hexadecimal is A, 11 is B, 12 is C, and 13 is D.
Then 14 will be E and 15 will be F. So this one will be DC.
So,
right, happiness, everyone.
So what is that? Let me just 18 plus 52. So hope everyone understood. So with this, we will stop for today's session. So I think for exam, we have just 2 more weeks to go. So let's have one more session like this next week. Hope everyone understood. Easy methods of solving the problems. At least I want some answers from. Okay, good. So they are the easiest ways of solving the problems. So, but you